Here are the answers for the section 8-6 homework about hyperbolas. On page 317, number 1, we're asked to graph, and we have this equation. So let's look at the form of the equation. It's got x squared, y squared. They both have denominators. It's equal to 1, and there's a minus sign. And it's the minus sign that makes this a hyperbola instead of an ellipse. Looking underneath x squared, we can figure out that a is 3, because it's the square root of the 9, which is a squared. The 25 is b squared, so we can get that b is 5. Now for hyperbola, what these values get you are the edges of a box. So from the center, on the x-axis, go left 3 and mark it, and go right 3 and mark it. On the y-axis, go up to 5, put a little mark, and down to -5 and put a little mark. Then draw a rectangle shape that crosses the axis lines at those spots. Next step, draw the diagonals of that rectangle. As you draw them, the diagonals will go through the center of the rectangle, which will end up being the center point of the hyperbola. In this problem, that is the origin, 0, 0. Each asymptote is a linear function that would have an equation or a slope if you ever needed to find them. Now, before we can draw in the hyperbola's branches, we need to know the type of hyperbola. Is it the kind that opens sideways like this, or is it the kind where one branch goes up and the other branch goes down? We have to know which we have. When the equation has the x squared term first and the y squared is minus, that is this first type, where the branches open sideways. Starting very close to the diagonal asymptote line, draw in the hyperbola curve, crossing through the edge of the box that we had marked where x equals 3. That's the x-intercept of this side of the hyperbola. Then on the other side, starting close to the asymptote, start curving that hyperbola line, making sure that you touch through at the -3, and then curve alongside the other asymptote line. So here in blue ink is our hyperbola. Number 3, what's the equation form we have? Does it match that of a circle, an ellipse, or a hyperbola? It has the minus sign, so it's a hyperbola. And because the y squared is first, it's the kind of hyperbola that goes up and down. Looking underneath y squared, we can see that a is 6, and looking under here, we see that b is 8. Let's mark those on the correct axes lines. The a equals 6 is associated with the y, so it's on the y-axis that you go up to 6 and down to -6. The b equals 8 is associated with the x this time, so on the x-axis go to -8 and +8, and draw in the rectangle. Do you remember what you do next? You draw the diagonals of the rectangle. Making sure to cross through the center of that box. Now we're ready to draw the hyperbola. Remember what type it is. The branches go up and down. So start close to the asymptote and start to curve so that you go right through that -6 at the edge of the box. And then curve up alongside the other asymptote. Down here, start really close to the asymptote and curve it going right through that -6 mark. And there's that side. Number 5, what equation form do we have? I don't see any denominators, so does that mean this is a circle? Well, nope, it's not a circle because of the minus sign. This is a hyperbola, and the denominators are 1s. So a is 1 and b is 1. Now the x squared term is first, so that's the sideways hyperbola. Go out 1 in all directions and draw the box. Then draw the diagonals. Now fit in the branches of the hyperbola. Number 7, what form does this fit? Well, it's got x squared and y squared, so it has to be a circle, an ellipse, or a hyperbola. It can't be the parabola. It has a minus sign, so I'm thinking a hyperbola, but it doesn't have the right form because it's got to say equals to 1. So let's divide everything by 16. 4 over 16 reduces to 1x squared over 4. And then minus y squared over 16, and now it's equal to 1. So a is 2 and b is 4. The x squared is first, so that's the side-by-side hyperbola. Let's make the box. And it's got to touch right at that spot. And over here, it's got to touch right at the edge of that box. Number 9, x squared and y squared again. And there's a minus sign, so probably a hyperbola, unless the sign changes as we're rearranging this. Let's subtract 8 from both sides. Then, to make a 1 over here, divide both sides by negative 8. So 2 over negative 8 reduces to negative x squared over 4. In this part, negative 2 over negative 8 reduces to positive, this was y squared over 4. And now it's equal to 1. Well, we don't want the leading term to have a negative here, so let's just reverse the order of the terms. This is a hyperbola because it did end up with subtraction in the middle. And a is 2, and b is 2. The y comes first, so this is the kind of hyperbola that goes up and down. Let's make the box. For the review assignment, we're going to go graph some of our other shapes. So you got to decide what you have. X squared, y squared, plus sign in the middle, and equal to 1. This is an ellipse. A squared is 25, so a equals 5. B squared is 9, so b is equal to 3. The a equals 5 is associated with x, so on the x-axis go to negative 5 and positive 5 and mark them. The b is equal to 3 is associated with the y, so on the y-axis go to 3 and negative 3. Now draw the ellipse. Number 4, what equation form does this fit? It's an ellipse. Remember, in an ellipse, you have to find values of a and b. And in an ellipse, a is always the larger number. So a is 10, but that's over here with the y, and b is 8. So on the x-axis, the b equals 8 gets us this dot and this dot. And on the y-axis, the a equals 10 gets us this dot and this dot. Now draw the ellipse. Page 311, we have another one to graph. Well, what type is it? It's got x alone. and y is squared. This is a parabola. And not only do we know it's a parabola, but when it goes x equals, that's a sideways opening parabola. And with a positive value here, it opens to the right. So we know ahead of time we want to get this shape right here. If we graph it and it doesn't make that, then something got mixed up. Let's make the vertex form, the one that has a minus sign in this spot. It would be x equals 1/2 times y minus -4. This matches our general form, x equals a times y minus k squared plus h, where h comma k gets us our vertex. So we can get our vertex. And let's record that vertex as the middle row of a chart. The vertex is h comma k. This -4 is the k, but what's the h? It's here on the end, and it is just a 0. So our vertex is 0, -4. Now count backwards from -4, -5, -6, and forwards from -4, -3, -2. Substitute these values into the original equation, which is right there. Let's fill in -3. -3 plus 4 makes 1. 1 squared is 1, and 1/2 times 1 is a half. And this will be a half. Now fill in -2. -2 plus 4 is 2. 2 squared makes 4, and half times 4 is 2. And this will be 2. Now we can graph. On the x-axis, I need to have enough marks to get over to 2. On the y-axis, I have to have enough marks to get down to -6. Two comma -6 is here. 1/2 comma -5 is here. 0, -4. Then 1/2 again, comma -3. And 2 comma -2. Here's the parabola. And it did end up opening to the right, just like our prediction. Number 8, let's graph this. Well, what one is it going to be? One of the variables is just linear, and the other variable is squared. That's when you have a parabola. And it's the x that's alone, so that's your sideways parabola. With a positive leading coefficient, the parabola opens to the right. Now this time on the right-hand side, we don't have a format that looks like vertex form. It looks like standard form. So A is 1, B is 8, and C is 6. And we'll get our vertex not with h comma k, but by using the formula. Oops, we're not doing x here though, right? We're working with y. This quadratic is in the variable y. So we're going to go y vertex equals -b over 2a. This is -8 over 2, which makes -4. Then we can get x vertex by substituting in -4. This is 16 minus 32, which is -16, plus 6, which is -10. In our xy table, in our middle row, x is -10 when y was -4. Now, in what column are we just going to throw in some numbers? In the x or the y? It's in the y. So counting backwards, -5, -6, and counting forwards, -3, -2. Now substitute into the original problem, this one right here, to figure out what x equals. So let's put in -3. -3 squared is 9. This makes -24, and 9 minus 24 is -15. -15 plus 6 makes -9. Now let's put in -2. -2 squared makes 4. This makes negative 16. 4 minus 16 is negative 12, and negative 12 plus 6 is negative 6. Notice between the vertex and the first dot, it's a change of 1 unit. And that's what it's always been every time the value of a has been 1. Notice that between the vertex and our next answer that we found, it was a change of 3 units. And that's what it's always been every time a equals 1. So by making those observations based on our experience, now that we've graphed many parabolas this year, we can tell that we are getting the right answers in the chart. Now we can make the graph. For the x-axis this time, it looks like we need to get all the way to negative 10. And on the y-axis, down to negative 6. Now graph the dots. Left 6, down 6. Left 9, down 5. Left 10, down 4. Left 9, down 3. And left 6, down 2. Then graph in the parabola curve.